Right, good morning everyone. Welcome back to our mathematics class. We're dealing with N4 and the sections that we are going to start with is simultaneous equations using Kramer's rule. Now, you have not done this before, okay? So this is not part of your grade 12 syllabus or even N3. So why am I starting with chapter 3 and not chapter 1? It's because this is a continuation from simultaneous equations in N3 and more specifically for the other groups who are doing engineering science and application subjects like industrial electronics, for the electrical students and even for the heavy currents and light current students, instrumentation, electrotechniques. They need an advanced technique to solve simultaneous equations. They will be given circuits, with resistance in parallel and series, and then you have different loops where you have to create your loops. So each loop will form an equation. So you might have 2 loops with 2 equations, 3 loops with 3 equations. That's what we're working towards here. Right, so we cannot go and work it out the long way. Okay, that's why you need a faster way, which is using Kramer's rule or determinants. Okay, so now I'm going to show you how this comes about. Okay, and how it came about. So here we have 2 equations. 2 equations, these are 2 linear equations with 2 unknowns, x and y. These are your constants. It could be like 2x plus 3y is equal to 4 or 5x. Right, a1, b1, a2, b2, c1 and c2 are just numbers. Now, if you recall, there are 2 methods for solving simultaneous equations. One method is substitution. Substitution works like this. It's either you make y the subject of the formula if you want to, or x the subject of the formula in equation 1, and then take it, substitute into equation 2, and then you work it out. So that is substitution. Then the second method is called elimination. That's the one I'm going to be using now. I'm going to show you how using elimination will get you to this rule here. And then you will learn a quick method to work it out. So now, using elimination. So using elimination, solve for x and y. So how am I going to do that? Okay. So if I want to solve for x, then I need to eliminate y from both equations. Right. If I want to solve for y, then I will have to eliminate x from the equation. So how will I do that? So let's take a simple example first. If I have, let's say, x plus 2y is equal to 3, and then I have x plus y is equal to 1. And if I want to solve for x here, okay, then I will have to eliminate y. If I want to solve for y, I will have to eliminate x. So, let's assume I want to solve for y. So, therefore, I need to eliminate x. So how will I eliminate x? I got 2 equations. Now notice the coefficients of x in the top equation and the bottom equation are the same. Okay, happens to be positive 1. Okay, but the whole point here is that it is the same. So if it is the same, that means if I go and subtract x minus x, I will get 0. You understand that? So once I get 0, that means x has been eliminated. So what I'm going to do now is I'm going to go top minus bottom. So I'm going top equation minus bottom equation. So my top is x, so I'm going to go x on the top minus x in the bottom. Then I got plus 2y on the top minus y in the bottom. I'm going top minus bottom equals to top we have 3 minus the bottom, which is 1 then. So what just happened now? We got x minus x, which becomes 0x, and then 2y minus y is just y, and then 3 minus 1 is 2. So 0 times anything is 0. So that's just 0 plus y is equal to 2. That means y is equal to 2. So x has been eliminated and we solve for y. Now, once we have y, there's no need to use elimination again. All you can do is take y, substitute into any one of these original equations, and then work out x. But now let's assume, let's go back again. Do the same thing. We got x plus 2y is equal to 3, and x plus y is equal to 1. So let's assume now we're starting from the beginning, and now I want to solve for x. So therefore I need to eliminate y. But we have a problem now. The problem is, if I go top minus bottom, will I get a 0y just like how I got 0x? No. Because the coefficient of y on the top is 2. The coefficient of y in the bottom is 1. So 2y minus y will give me y. It doesn't eliminate y. It doesn't give me a 0. So before I do the subtraction, I have to make both coefficients equal. Okay. So I have an option. I can divide the top equation by 2, because 2 divided by 2 will give me 1. So what am I saying? If I divide by 2, so I'm going to go 1 over 2 times x plus 2y is equal to 1 over 2 times 3. Divide by 2 is the same as multiplying by 1 over 2. Whatever I do on the left hand side, I must do on the right hand side. So what will happen here is 1 over 2 times x is 1 over 2x. 1 over 2 times 2y is going to give me 1y. 1 over 2 times 3 is 3 over 2. Now, both equations have the same coefficient. Can you see that? So I can subtract. But the problem is now, okay, it's not really a problem, but we now have fractions. We've created fractions. So we will try, let's try, and instead of dealing with the first equation, why not deal with the second equation? What can I do to the second equation to make these two numbers become equal? Multiply by 2, exactly. So that's a better option. Okay, there's nothing wrong with doing this. Yeah? It will work perfectly. It's just that you have fractions and people make mistakes when they deal with fractions. So now, it's better to multiply by 2. So what will happen now? So I've got my x plus 2y is equal to 3. That is my top equation. Bottom 2 times x is 2x, 2 times y is 2y. And don't forget the right hand side, 2 times 1 is 2. So now there's no fractions there. It's easier to do the subtraction. So now I'm going to go top minus bottom. So I have to do it term by term. Top minus bottom, so I'm going x minus 2x plus 2y minus 2y is equal to 3 minus 2. So what happens here? 1 minus 2 is minus 1x. 2y and minus 2y is just a 0. And 3 minus 2 is 1. So therefore x is equal to 1 divided by minus 1. Because minus 1x is equal to 1. You can see that? So it's equal to just minus 1. So that is elimination. Now, let's do it in general for any number. Okay, so here I just chose anything, I just made it up now. I chose, this is a 1, that's a 2, that's a 3, that's a 1, that's a 1, That's also a 1. So now we're going to do it for any number. So we are going to be using elimination, and I'm going to show you how Kramer's rule comes about. So we have a problem now. Here, this is A1, A2. None of these coefficients are the same. Can you see that? So, if I have something like this here, let's say if I have minus 3x on the top and I have minus 2x in the bottom. Let's just put plus y is equal to 4 plus 2y is equal to 3. Let's take these two equations. Now, if I want to eliminate x here, I need to make the coefficients of x to be identical, the same. So, all I have to do is, I look at the top equation and the bottom equation. Let's say I want to eliminate x and I want these two to be equal. So, I will multiply the top equation by the coefficient of x in the bottom equation. And then I will multiply the bottom equation by the coefficient of x from the top equation. So I got minus 3 here. I multiply, look at the coefficient here. It's minus 2. Then I'll take this one and multiply by the top. Minus 3. So what does this do now? So I got minus 2 times minus 3x, which becomes a positive 6x. Then minus 2 times y is minus 2y. And then minus 2 times 4 is minus 8. The bottom equation, minus 3 times minus 2x is going to be 6x. And that was the aim of this whole thing here. Can you see that? To make these two numbers equal, then I can go top minus bottom. So then I've got minus 3 times 2y is minus 6y, and minus 3 times 3 is minus 9. So, if these two numbers are not the same, all you do is multiply the top equation by the coefficients of the variable that you want to eliminate in the bottom equation. Right, so that's exactly what I'm going to be doing here. Just that it's taking a bit long because I'm explaining it in detail, but this does not take very long when I do the actual Kramer's rule. So now, this is what I want to do now. I want to solve for x first. So I'm going to eliminate y. That's what I want to do. I'm going to eliminate y. Right, so now, if I want to eliminate y, that means I will have to multiply the top equation by the coefficient of y from the bottom equation, and the same the other way around. So let me just do that quickly. So what I'm going to do now is, I'm going to take the top equation and multiply it by, what will I multiply it by? What will I multiply it by? Remember, I want to eliminate y. So I'll need to multiply the top equation by the coefficient of y in the bottom equation. So this is going to be b2. Can you see that? Then I will multiply the bottom equation by the coefficient of y from the top equation, which is b1. Now let's see what happens here. So now if I multiply it, I'm going to have a1 b2x plus b1 b2y. That is my left hand side. Right, so that is the left hand side. Now don't forget, whatever I do on the left hand side, I must do on the right hand side. So that's going to be b2 times c1. Alright, now the bottom equation I'm going to multiply by b1, so that's going to be a2 b1x plus b1 b2y is equal to b1 c2. Okay, so now what just happened? Now the coefficients of y are the same. Can you see that? b1 b2 B1, B2. So now I can go and subtract. So now I'm going to go top equation minus bottom equation. Alright, so that's going to be top minus bottom. So let me just do this in detail here. So my top equation minus the bottom equation, so that will be A1 B2x on the top, A1 B2x, subtract minus A2 B1x, that is top minus bottom, and then top minus bottom again, we got plus B1 B2y minus the bottom there, which is B1 B2y, is equal to right hand side, that will be B2 C1 on the top minus B1 C2 in the bottom. What do you notice now? That these two, the coefficients are the same, so the result here is a 0. So we are left with only the variable x. So from these two here, I can take out a common factor of x. So I'm now left with A1 B2 minus A2 B1. This here is a 0. And then now I have B2 C1 minus B1 C2. And finally now x is equal to B2 C1 minus B1 C2 all divided by A1 B2 minus A2 B1. And this is the formula now. In general, for any equation to solve for x, if you're eliminating y, any number, if you have two linear equations, it must be linear. Okay, it can't be x squared and y squared. That is going to be like a circle, a quadratic. Okay, so linear equation, the highest power of x must be, the highest power of your variables, both variables must be just the one. You can't see the one, but you know. If there's no number shown, it is a positive 1. Alright, so now, it took a while to get to this. Alright, this is not the Kramer's rule, but Kramer's rule will be, you'll be able to get to this step much quicker. Okay, but this is for your understanding now. How does this come about? So let me do the other one now. Let's go back again. And this time, let me copy down the equation. So I got A1x plus B1y is equal to C1, and then I got A2x plus B2y is equal to C2. So what I want to do now is, I want to solve for y. So I'm going to eliminate x. Solve for y, so eliminate x. So if I want to eliminate x, that means I need to multiply the top equation by the coefficient of x in the bottom equation, and then multiply the bottom equation by the coefficient of x in the top equation. Okay, it's the same process. So there's my top equation, there's my bottom equation. So now I want to eliminate x, so I multiply the top by the coefficient of x in the bottom, which is A2. And then I multiply the bottom equation by the coefficient of x from the top, which is A1. So what happens now? All I'm going to do is multiply. So that's going to be A1 A2x plus A2 B1y. That is my left hand side. On the right hand side, A2 times C1 is going to be A2 C1. Bottom equation, this is going to be A1 A2x plus A1 B2y is equal to A1 times C2, that will be A1, C2. So what just happened? We multiplied. Now look at the variable x. Look at the coefficients here. But do you notice A1, A2, A1, A2, they are the same. So if they are the same, we can subtract. So now I'm going to go top minus bottom again. So if I go top minus bottom, so here's it, A1, A2x, here's my top, subtract the bottom, minus A1, A2x, those are my x terms now, the y's, so that's going to be plus, I got A2, B1y, minus the bottom one there, which is A1, B2y, and then the right hand side, top minus bottom again, that's going to be A2, C1 minus A1, C2. So what happens here is, these two are identical, so when you subtract, you get 0. Here, I can take out y as a common factor. So if I take out y as a common factor here, I'm left with A2, B1 minus A1, B2. So now I can just make y the subject of the formula, so that becomes A2, C1 minus A1, C2 all divided by A2, B1 minus A1, B2. And that is the formula for any equation, any two linear equations if you're solving for y. Right, so copying is, you can take a picture if you want to be faster instead of copying it down. Okay, so now I've shown you simultaneous equations using elimination. You saw how we got x and how we solve for x and y. Now, right, so we'll refer back to this in a few minutes. Now, you're going to learn the advanced technique for working out simultaneous equations called Kramer's rule, or basically determinants. Okay, so what is a determinant? So a determinant, basically, you have two lines here and you have numbers inside. Okay, it's a square mathematical grid consisting of an equal number of rows and columns. So we're going to be talking about, we'll always be referring to rows and columns. So rows, remember rows are horizontal, so you got row 1, row 2, row 3. Columns are vertical, so you go column 1, column 2, column 3, and so on. So this is a determinant. Then we have numbers inside. You can call them numbers or elements. How do we identify these numbers? You will identify them by the specific row and column in which they lie. So in a case like this here, let's have a look at this. This is a determinant. It's a 2 by 2 determinant. What does 2 by 2 mean? It means there are 2 rows of numbers and 2 columns of numbers. So let's have a look at this. So you have this determinant. Here's row 1. In row 1, what do you see? You see the numbers 2 and 4. In row 2, you see the numbers 3 and negative 1. Now if you look at it from top down or bottom up, it's column 1. The numbers that you see in column 1 are 2 and 3. The numbers that you see in column 2 are 4 and negative 1. Alright, so rows and columns. Now, how do you evaluate a 2 by 2 determinant? How do you work it out? Right, so this is the formula. So here you have your determinant. You got these numbers there. How do you work it out? You will start with the top. You take the number on the top left hand side and you multiply it going down like a diagonal. So you're going to take that number multiplied by this number. So it's going to be A1 times B2. You put a minus sign, and the minus sign is part of the formula. Where does it come from? It comes from elimination. There's the negative sign. Can you see that? Those are the negative signs. So now you put a minus sign, and now you will start from the bottom, the first number, bottom left, and then you multiply going up. So you just remember the cross going down, multiply, put down a minus sign, and then going up, you multiply A2 times B1. Very simple thing to do. You will see this whole section is easy. I think even I can take a grade 9 student and teach them this year, they will get full marks. You will see when we're done with everything. So now, let's evaluate this determinant. So, we're just going to multiply going down. You don't have to go and put down a line, it's just to show you that we are multiplying this way. So it's going to be 2 times minus 1. So that's my multiplication. Now you put down a minus sign, which is part of the formula. And then now you multiply going up. So that's going to be 3 times 4. And then you just work it out. So 2 times minus 1 is minus 2, and then 3 times 4 is 12. So minus 2 minus 12 is minus 14. And so that's evaluating a 2 by 2 determinant. Let's do this one. So here, that's going to be equals. So don't forget your equals to sign. So we multiply going down, so that's going to be 3 times 1 over 2. Then you put down a minus sign, so going down, put down a minus sign, and now multiply going up. So that's minus 1 times 2. Simple thing to do, you can see that. So now, 3 times 1 over 2 is the same as 3 over 2. Negative times a negative there, that is a positive 2. So 2 plus 3 over 2. So this is the same as 3 over 2 plus 4 over 2, which is 7 over 2. Same thing. Which is the same as 3.5. Now, obviously, you don't have to go and show all working here. You got your calculator, you just get your answer one time. But you have to show at least the multiplication part here, and then from there, straight to your final answer. So what we're doing now is we are learning how to evaluate a 2 by 2 determinant. So copy this down, and let's see if you can work out the value of P here, if you understand the process involved. Alright, so you tried out, you had a look at number 1. Number 2, remember, when you're evaluating a determinant, it's always starting at the top, going down. You multiply these two numbers like a diagonal, they're going down, then you put a minus sign, there's a minus sign here. Minus sign, and then you start from the bottom, and then a diagonal, like a cross, going up. So that time, this minus sign is part of the formula. So now, you're given something with an equals to sign. It's like an equation. You've got a determinant on the left, a number on the right. So don't get confused. Right, so what we're going to do is we start from the top, going down. So that's going to be, now remember, the equals to is here. For this question, you are answering it, so now you're putting down the equals to sign. But this was given to you. So there's my equals to here now. 4 on the right hand side. Can you see that? So on the left hand side, we got 2 multiplied by minus p. So it's always that times that. Then you put a minus sign down, and then you start from the bottom up there. So that's going to be half times 1. So now it's a simple linear equation. We just needed to know how to evaluate. All you do is down, put a minus sign, up, multiplication, simple. So 2 times minus p is minus 2p, and then minus half times 1 is minus half is equal to 4. And now let's isolate minus 2p. So we got minus 2p is equal to 4 plus half. So now I have minus 2p is equal to 9 over 2. So now p is equal to 9 over 2 divided by minus 2, which is the same as minus 9 over 4. Minus 2 and 1 over 4, correct? But now I'm showing all working here. Obviously, you do it one time on the calculator and get your answer. The main thing you need to know is how to evaluate the 2 by 2 determinants. 2 by 2 means there are 2 rows of numbers. You got row 1, which is 2 and 1, then you got row 2. You got 2 rows and 2 columns. That's why it's called a 2 by 2. So we are dealing with 2 by 2 and then 3 by 3. Okay. That's part of the N4 syllabus. Now, let's have a look at how we're going to get to that, but in an easy way now. Okay. So this is Kramer's rule, determinants. These are 2 linear equations. We want to work out x and y. So the formula, we're going to work out x. It's given by the formula dx over d. And then you're going to work out y, it's given by the formula dy over d. Okay, so now we're going to work out our dx, our dy, and our d, substitute, and then work out our final answer. Right, so what is common here is the denominator d. Can you see that? So what is d? So d is called the determinant of coefficients. Right, so how do we do this? You write down d equals to, put down your 2 lines, like absolute value, 2 straight lines there, and then make sure your equations are in order. Don't have x this side, y on the other side of the equation. It must be x, y equals to a number. Then you got second equation, x, you got your y variable equals to number on the right hand side. So if this is in order, then now determinant of coefficients. You copy the coefficients of x and y in order. So what are the coefficients of x? It's a1, a2 in order. Don't write down a1 and a2 there. It's a1 on the top, a2 in the bottom. Then we got b1 on the top, b2 in the bottom. So what do? We have a 2 by 2 determinant. Now, work it out, evaluate it. So if I'm evaluating this, I'm going to go top, and then multiply in the diagonal, so that's going to be a1 times b2. Put down a minus sign, and then you go up, it's going to be a2 times b1. Now, that is d, the determinant of coefficients. Easy. Just copy down the coefficients of x and y, evaluate it. Now, let's do the dx part. So, dx. Okay, how do we do this? Let me write that down. So here, you need to replace the coefficients of x from d. That means you go back to d, replace the coefficients of x from d with the constants. The constants from the original equation are C1 and C2. So let me just show you. It's a simple thing to do. If I'm working out dx, I will replace the x column of coefficients with the constants. So remember, this represents the x column. It's the coefficients of x. Can you see that? This represents the y column, the coefficients of y. If I am finding dx, I will replace the coefficients of x. So there's the coefficients of x. That means I will remove it and now replace them with C1, C2. So I got my C1, C2. The original B1 and B2, I did not touch anything. There's my B1, B2. What do you do now? Evaluate it. It's a 2 by 2 determinant. Work it out. So I'm going to go C1 times B2 minus C2 times B1. Okay, now let's do dy. So for dy, I'm sure by now you must be already thinking what I'm going to be doing. So if for dx I replace the x column, what do you think I'm going to do for dy? I'm going to replace the y column. So let me just write it down first. I'm going to replace the coefficients of y . So let me do it now. You go back to your determinant of coefficients. This time, if I'm working on dy, I will replace the y column with C1, C2. So there's my, to remove this, write down C1, C2, and the original x column you do not interfere with. You leave it as it is, which is A1, A2. So once you got that sorted, now evaluate it. So that's going to be A1 times C2 minus A2 times C1. And now we're done. All you have to do is substitute. So substitute into this formula. Let's see. Let's write it down. What do we get? So let's go for y. Y is equal to dy over d. So what was my dy? It was a1c2 minus a2c1 all over d, which was a1b2 minus a2b1. So that is my final answer for y. What about x? X is equal to dx over d. What was my dx? There's my dx here, which is c1b2 minus c2b1 over the original d. D does not change, it's the same. And that's Kramer's rule. So look at x. Look at x here. C1b2 minus c2b1. There's it here. C1b2 minus c2b1. Same thing. Can you see that? So this was using elimination. This is getting to it in a few, it only takes less than a minute if you're fast with this here. Alright, so now you are ready. We're now going to be working out simultaneous equations using Kramer's rule. Okay, so now we're taking some examples straight from the exercise, from your textbook, exercise 3.6. So using Kramer's rule, solve for the unknown variables. So you're going to see how easy this is, that you can even go and teach somebody who's still in school, like maybe grade 9 or 10. Very simple. What you need to do is make sure your equations are in order. Okay, both these equations are in order. Okay, but it's best to write them one below the other. So here I've got x minus y is equal to 3. Make sure you know your coefficients here. The second one is x plus y is equal to 6. So what do we need to find? Three things. Just d, dx, and dy. So my d, then I will need to find dx, and then dy. So d is the determinant of the coefficient. So make sure in the beginning you got everything 100% here. So the coefficients of x are 1 and 1. You can see that. So that's a 1, 1. And the coefficients of y, minus 1 and a positive 1. So that is minus 1 and 1. So what do we do? Write it down. Evaluate your 2 by 2 determinants. So that's going to be 1. Remember, you always start with the first number. Going down diagonal. So that's 1 times 1. Put down a minus sign. This minus sign is part of the formula. Okay, then you go up. So that will be 1 times minus 1. So we know 1 times 1 is 1. Negative times negative is a positive 1. So 1 plus 1 will give me 2. So that's the value of d. Now dx, what do? We replace the coefficients of x from d. We basically replace the x column. So there's the x column here. Replace it with the constants 3 and 6. The y column will remain the same. So that will be minus 1 and 1. What do we do now? Evaluate it. So multiply going down. So that's going to be 3 times 1 minus 6 times minus 1. So we know 3 times 1 is 3. Negative times a negative is positive 6. So 3 plus 6 will give me 9. Very simple. You can see that. For dy, what do? Go back to d. D is the main thing. But this time, replace the y column. If it's y, replace the y column. If it's x, replace the x column. So, replace the y column with 3 and 6. And then we got, so replacing the y column, the original x column, you don't touch it. It will remain how it was already, according to d. Now, evaluate it. Go down, so that's going to be 1 times 6 minus 1 times 3. So that's 6 minus 3, which is equal to 3. So now, you got all that information. Make sure you don't forget your equals to sign. You draw, these are two lines here, straight lines, okay? Two, these absolute value lines, one straight there. So now, x is equal to dx over d. What was my dx? It was 9. And d, 2. What was y? Y is equal to dy over d. What was dy? 3. d, 2. You're done. It depends on how fast you are. But obviously, be careful with this here, because if you make a mistake in the beginning, when you rearrange, maybe you, instead of 3 you went and wrote down a minus 3, then obviously everything is going to be wrong. So make sure you check your question properly. So 9 over 2 is the same as 4.5, and this is going to be 1.5. Right, so let me give you a few minutes, deal with this, and then we move on to the 3 by 3. 3 equations with 3 unknowns. Right, so number 1, we worked it out. Remember, you need to check your answer. You check your answer by substituting into the original equations, both x and y. Check if the left-hand side is equal to the right-hand side. Don't check one, check both, because they must satisfy both equations, not just one equation. Right, so now, let's move on to the next one. So here we are working out a and b. So here we got 2a minus 3b minus 6 is equal to 0. A is equal to b plus 7. Equations are not in order, so rearrange them. So here I have 2a minus 3b is equal to 6, and this one a minus b is equal to 7. Or you could have done it like this. See, let's say you took everything to the right. You could have had minus 2a plus 3b is equal to minus 6. Okay, that means if you took 2a to the right, it became minus 2a. Minus 3b to the right, it became plus 3b. You could have taken this to the right, it would have become minus a plus b is equal to minus 7. It depends on what you're doing. It's either you're taking everything to the left or everything to the right. The final answer will still be the same. There's nothing wrong with taking something to the right. So it's up to you. It's just that the working out, the signs will be a bit different in the working out, but the final answer must be the same. Alright, so now your equations are in order. Now, simple. D, okay, there's no x, it's going to be dA and dB. So let's write it down. We've got D, then we have dA. Remember, equals to. This is where people lose marks. Okay, because you're not following what's on the board. So it's equals to here, make sure your lines are straight. So that's dB. For the 2 by 2, you'll get 5 marks or 6 marks, it depends. For 2 equations. And we come to 3 equations, it's 8 marks to 10 marks. So D is the determinant of the coefficients of A and B. So the coefficients of A are 2 and 1, the coefficients of B minus 3, minus 1. Now evaluate, so that's going to be 2 times minus 1 minus 1 times minus 3. So we get minus 2, negative times negative is a positive. So therefore 3 minus 2 is a positive 1 for D. Okay. Here, for dA, you're going to replace the A column or the coefficients of A with the constants 6 and 7. Right, so you're replacing the A column, but the B column will remain the same, minus 3, minus 1. Now evaluate. So that's going to be 6 times minus 1, put down a minus sign, and then it's 7 times minus 3. So you get minus 6, and negative times a negative is a positive, 21. So 21 minus 6 is 15. That's your dA. Now dB, go back to the original determinant of coefficients. This time, replace the B column or the coefficients of B with the constants 6 and 7. The original A column must not change. The original coefficients here, so that will be 2 and 1. Easy. Now evaluate. So that will be 2 times 7 minus 1 times 6. So 2 times 7 is 14 minus 6, which is equal to 8. Right, so now let's work out our final answers. So A is going to equal to dA over D. There's no x here, so you write down A. So what is my dA? It is 15, and D was 1. 15 divided by 1 is 15. Then we got B is equal to dB over D. So what is my dB? It is 8 over 1, which is 8. You check your answer. Easy. Most of the students every year get full marks for this chapter 3. It's around 8 to 10 marks in your exam. It depends. Now, this is not the 8-mark question. This is still the easy one. In fact, everything is easy. It's just that the 3 by 3 takes a bit longer to work out. Alright, let's deal with one more. Number 4. Right, so number 4, we got unknowns P and Q. But clearly these equations are not in order. They are not in standard form. So get all our unknowns on one side. So what do we have here? We got 2 over 3. P minus 3 over 4. Q, take your constants to the right hand side. Second equation, we got 1 over 2. P minus 2 over 3. Q is equal to 6. Now, remember you could have taken P to the right hand side and made it minus 1 over 2P. It's up to you. There's no need to go and find LCD. Okay, as long as your terms, basically you have terms, they are separated here. You don't have to go do any extra work and find LCD. The main thing is you have everything in order. So now we need to find D and then dP and then dQ. So D is the determinant of coefficients. So the coefficients of P are 2 over 3, 1 over 2, minus 3 over 4, minus 2 over 3. Right, now evaluate it. So that's going to be 2 over 3 times minus 2 over 3 minus 1 over 2 times minus 3 over 4. So we get minus 4 over 9. Negative and negative is a positive. 3 over 8. So that's going to equal to minus 32 plus 27 all over 72, which is equal to minus 5 over 72. You got that? For D, minus 5 over 72. Got it? Right, so GP now. So for GP, we replace the P column with the constants 7 and 6. The Q column will remain the same, which is minus 3 over 4 minus 2 over 3. So now, once you write this down, evaluate it. So now this is going to be equal to 7 times minus 2 over 3 minus 6 times minus 3 over 4. And now, let's see what we get. So that's going to be minus 14 over 3. And that's going to be 3 plus 9 over 2. So then we get minus 28 plus 27 over 6, which becomes minus 1 over 6. So that is my dP. Then for dQ, go back to the original determinant of coefficients and then replace the Q column with the constants 7 and 6. The original P, coefficients of P will remain the same. Evaluate. So that's going to be 2 over 3 times 6 minus 1 over 2 times 7. So we get 4 minus 7 over 2, which is the same as 8 over 2 minus 7 over 2, which is the same as half. Now, let's work out our final answers. So we know that P is equal to dP over d. My dP was minus 1 over 6 and d was minus 5 over 72, which is the same as minus 1 over 6 times 72 over 5. So that's going to be minus 12 over 5, which 5 can, so that's minus 2 and 2 over 5, correct? Minus 2 comma 4. So P is minus 2 comma 4. You got that? Now Q is equal to dQ over d. What is my dQ? dQ was 1 over 2. D is minus 5 over 72. So it's the same as 1 over 2, invert and multiply there. 72 divided by minus 5. So that's the same as minus 36 over 5. Which is going to be minus 7 comma 2. So final answers, minus 2 comma 4 minus 7 comma 2. Got it? Check your answer.
So if you leave your answer, it should say 36, like you're going to put 36 over 5, and you don't carry it.
No, it's fine. If you leave your answer like this, it's still correct, full marks.
Right.
Yeah, it's still correct, because this is the final answer. Just that I simplified it further. Alright, so now, before we end, we need to know how to deal with this 3 by 3 determinant. So just copy this down quickly. Okay, so now dealing with a 3 by 3 determinants. So what does 3 by 3 mean? It means there are 3 rows and 3 columns of numbers. So here's row 1. In row 1, if you want to in pencil, you can write down R1. Okay, just so you don't forget that that is row 1. So row 1, we see the numbers 2, minus 1 and 3. Then row 2, and then we got row 3. Then if you look going down, that will be C1, that's column 1, C2, column 2, and C3, column 3. Right, so now, in our way, this is the last thing we're going to be doing, solving for x, y, and z. This time there's 3 unknowns here. So, we first need to know how to evaluate, just like how I taught you that when you evaluate this, you multiply going down, put a minus sign going up. Okay, now, here, before we come to that stage, you need to know the definition, how to work out the minor, and then the cofactor, and then once we know the cofactor, then you can evaluate your determinants. So, now, M stands for minor, C will stand for cofactor. So what does the minor mean? Now, you say M1, 2. What does that mean? How do you read that? So M, I, J. So in the order of I first, J second. That means the first number that you are reading refers to the row, and the second number refers to the column. So when we talk about M12. So let's do this one here. So work out the minor of row 1, column 2. Okay, so where is row 1 and where is column 2? Can you see row 1, column 2? Yes. Now, what you're going to do is, here's row 1. Can you see there's row 1 here? And there's column 2. So what's going to happen is you're going to draw your determinant line here, and you are going to block out all the numbers that lie in row 1 and all the numbers that lie in column 2. When I say block it out, just take your hand or pencil and block. There's row 1. If I block row 1 and I block column 2, what numbers remain now? Can you see the numbers that remain here? I'm blocking row 1, column 2, so I'll block row 1, block column 2, and I'm left with only these numbers here, which are -2, 4, -3, 5. So that is how you determine, that's how you write down the minor, and now it's a 2 by 2 determinant now. Can you see that? So what do? We know how to evaluate. Let's evaluate this one. -2 times 5 minus 4 times -3. So -2 times 5 is -10, -4 times -3, that's going to be plus 12, and 12 minus 10 is 2. So it simply means block out the row, block out the column, and write down the remaining numbers that you see all the time. That is minor. That's 1.1. Let's do 1.2. The minor of element -4. Now, it's the same type of question but asked in a different way. Can you see -4 there? Can you see -4? Which row and which column is that? Row 3, column 2. So simply means block row 3 and block column 2. So the minor of element -4, that means M32. That's what it means. The minor of element -4. -4 lies in row 3 and lies in column 2. So it's M32. That means block row 3, block it out, block column 2, and write down the remaining numbers there. Okay, so block row 3, block column 2, you are left with 2, -2, 3, -3. So that's 2, -2, 3, -3, and now simply evaluate it. So that's going to equal to 2 times -3 minus 2 times 3. So that's going to be -6 plus 6 there, which is a 0. So that was M32. M22 now. You know, it's a simple. I told you the whole section is simple. Okay, blocking a row, blocking a column. So M22, it means block row 2, block column 2. Can you see it? Eventually, for now, you take your pencil and block it. Eventually, you just use your mind and block it off. Okay, so you block row 2, block column 2. So you're left with 2, 4, 3, 5. Can you see that? Evaluate it. So that's going to be 2 times 5 minus 4 times 3. So 2 times 5 is 10, 4 times 3 is 12, 10 minus 12 is minus 2. And that is how we find the minor of a 3 by 3 determinant. Now, you see the letter C. C stands for cofactor. So, this is the formula for cofactor now. It's equal to the minor Mij. So in order to find the cofactor, you have to find the minor. But now there's something in front here. It's always going to be a minus 1 to the power I plus j. So the only difference between the minor and the cofactor is the minus 1 to the power something in front. So you're going to find the minor, you need to work this part out. When you take minus 1 and raise it to a number, the answer could only be a positive one, or it could be a negative one. What am I saying? You're going to see the minus 1 to the power 2. If it's an even number, it's always going to be positive 1. If I got minus 1 to the power 3, if it's an odd number, it's always going to be negative. It depends on what you work out here. Depends on the row and the column. If the row is 1, the column is 2, 1 plus 2 is 3, and then we got minus 1 to the power 3. Right, so let's do this one here. C12. So I'm going C12. So what does that mean now? It's row 1, column 2, that means I is 1, J is 2. So the formula works like this, minus 1 to the power I plus j, that means add these two numbers up, 1 plus 2, times M12. I is same I, it's the same j there. So now, we got minus 1, 1 plus 2 is 3, and what is M12? M12 means the minor, so block row 1, go back to where's the original name, block row 1, and block column 2, so that's minus 2, 4, minus 3, 5. So, minus 1 to the power 3 is minus 1. You need to work that out. Then you work this part out. It's multiplication. So that's in brackets minus 2 times 5 minus 4 times minus 3. So you're going to get minus 10 plus 12, which is 2. And then finally 2 times that minus 1, which is minus 2. Now let's do it's easy this year. Just block a row, block a column, and work it out. Which one? This one. You see, there's a negative here. There's your negative. So we work this out. Minus 10 plus 12 is a positive 2. But remember that the negative 1 needs to be multiplied by whatever answer you get here. So a negative times a positive will be negative. Remember, you're looking at this. This was a positive 2 for only the minor. But now, we don't have only the minor, we got the negative 1 to multiply. So negative times a positive will be negative. Right, let's finish these two here. And then I can just guide you on how to evaluate, which you will do at home. Just need to show you how to evaluate this 3 by 3. Once you know how to evaluate, then you are ready to work out simultaneous equations. Let's work out 1.5, 1.6 there quickly. Right, so 1.5, the cofactor. The cofactor of element negative 3. So there's negative 3. Which row and which column is that? Row 2, column 3. So that's C, 2, 3. So to work out cofactor, it is minus 1 to the power. You add this up, I plus j. So 2 plus 3 will be 5. Here it was 1 and 2. 1 plus 2 gave you 3. Times m2, 3. Okay, so minus 1 to the power 5 is minus 1 times, now m2, 3. That means block row 2. Here's the check. Block row 2, block column 3. So we are left with 2, 4, minus 1, minus 4. And now evaluate. So that's going to be minus 1, and then I got 2 times minus 4, minus 4 times minus 1. So 2 times minus 4 is minus 8. Negative times negative is a positive 4. So minus 8 plus 4 is minus 4. And then negative times a negative, then positive 4. So that was 1.5. One point 6 you can work it out. I just need to give you another instruction here which I'm going to show you, and then you're going to try it out at home. Right, so now that you know how to work out the cofactor, you are now able to evaluate this determinant. Just like how we evaluated all those determinants, the 2 by 2 determinants. Now we are using a method of cofactor expansion. Right, so this is called cofactor expansion. There is another method to evaluate a 3 by 3 determinant. Okay, but you have to know both methods. The other method is much easier or much shorter, okay, than what we are doing now, but you have to know both methods. Okay, so here to evaluate this 3 by 3 determinant, there are 6 different ways to do it. Why? Because there are 3 rows and 3 columns. So you can expand along row 1, row 2, row 3, row 4, row 6. You must come to the same final answer. That's what you're going to be doing at home for practice. Right, so let's have a look at 2.1. If I ask the question now, it's not asking you to find the minor, you're not asked to find the cofactor. The question is work out the whole thing, evaluate the above. Okay, so how do you do that? You are given a specific instruction, row 1. In the exam, they will tell you specifically, maybe row 1, column 1. We can't have everyone doing different things, right? Because there will be 6 different working answers. But the final answer must be the same. So how do you expand along row 1? What numbers do you see in row 1? What numbers do you see? You see 2, -1 and 3. So if I want to evaluate this determinant, this is how I'm going to answer it. Along row 1. So I've got 2 is the first number times the cofactor of 2. What's the next number that you see there? -1 times the cofactor of -1. What's the last number that you see there? 3. So that's a +3 times the cofactor of 3. All in one line. So basically what you're going to be doing, you're going to be doing this here. How many times? 1, 2, 3 times. Nothing difficult, it just takes a bit long to write down. So you'll work out the cofactor of 2 and multiply it by 2. Then you'll work out the cofactor of -1 and then multiply it by your answer by -1. So what does this mean? It means 2 times. What is the cofactor of 2? If I have to write it in terms of C there, so that's C11. What's the next one then? -1 times the cofactor of -1. Which row and which column is that? It's row 1, column 2. -1 times C12. What's the last number then? 3. So it's +3 times the cofactor of 3. The cofactor of 3, that is row 1, column 3. So that is C13. So you have to, obviously, you're going to work all this out and you'll get your answer. Let's take column 1. Let's take column 1. You might be wondering, how do I expand along column 1? What numbers do you see in column 1? You see 2, -2, and 4. So it's the same thing now. 2 times the cofactor of 2. What's the next number going down now? -2. So it's -2 times the cofactor of -2. What's the last number in column 2? 4. So it's going to be +4 times the cofactor of 4. So what does this mean? It means 2 times the cofactor of 2 is C11. The next one, -2 times the cofactor of -2. That's row 2, column 1. So that's C21. What's the last one? +4 times the cofactor of 4. What row and what column is that? That is row 3, column 1. So this is how you evaluate a 3 by 3 determinant using the method of cofactor expansion. So once you do this, then you are now ready to work out simultaneous equations with 3 unknowns. But we will continue with this. And we're moving on to complex numbers, which is chapter 5.
Next week.
Yes, we finish up with this and then we move on to complex numbers.